Imagine in the future if designers and manufacturers will have instant feedback how their products are being used. We're seeing that approaches like performance-aided design will help to accelerate that development from design simulate to make. Now, designers and manufacturers will be able to iterate much faster and deliver products to the market much quicker.
We're a company that designs software so people can make anything. We have a fully equipped state-of-the-art shop where we have additive, subtractive, hybrid manufacturing, and we have a suite of equipment that supports everything that people need to do to prototype and iterate to make their ideas come to life.
So Autodesk Research, we look 5 to 10 years out from product. So we're trying to make sure that we don't fall into any blind spots, that we de-risk new technologies that are coming out. We end up using the Markforged printers and parts in all of our projects. End effectors, gripper fingers, jigs for positioning parts, kits. It kind of gets used everywhere.
Currently, we're working on a product called performance-aided design. What we're trying to learn from this research is, can we use data that's been gathered by systems that operate? What I mean by this is like an autonomous vehicle. The data that they use keeps that vehicle on the road, but can we actually utilize that same data to understand the physical performance of that vehicle and bring that back to the designer to see if the designer can actually utilize that and improve that design?
Traditionally, when products are designed and made and they're used by the customers, designers are only seeing whether their products perform well or not after years. So it takes years for designers to even iterate on one version of their designs, because all of that feedback is currently getting through the warranty information and then is being shared with the design and simulation teams. So the main difference between the traditional design and performance-aided design is getting the information from the product's performances through the sensors and digital twins and closing the gap between simulation and reality.
For performance-aided design, we're building 2 different UAV platforms. One has a 55-pound max takeoff weight, and the other one has a 300-pound max takeoff weight.
We chose a UAV because of the amount of data that it needs to gather to stay in flight. UAVs tend to go through a lot of dynamic loading conditions. Wind gusts hit it, landing, takeoff, heat changes at sea level to up to 400 feet. All these things changes the performance of the UAV. So it gives us an incredible platform to apply our research to.
Our design team leveraged the FX20 heavily in our UAVs because of the large build volume, being able to do big builds all at once. We wanted robust electronics enclosures that would stand up to being out in the sun all day. So the high temperature plastic was really important. The end of the arms for the UAV are 3D printed on the FX20 with a bunch of continuous fiber reinforcement. So really tight volume constraints on the design, and we needed that high stiffness to take up the actual flying loads of the vehicle. So this is part of the motor mount structure for our 300-pound UAV. So there's an aluminum motor plate that mounts on here, a carbon fiber boom that gets clamped in here, some sensors that get mounted. We 3D printed this part of the boom because of the complex shape and because we figured out it could be strong enough if we packed this area with fiber. One of the design challenges that we've overcome through the course of this UAV research is a real practical everyday one. In our 300-pound UAV has gone through a number of iterations, and we've been able to do design work in the UK and in Canada and Boston and San Francisco, and print all of it in different locations and rapidly iterate on it.
When I'm making pitches of what to purchase at our sites, what really matters to us are machines that work well, machines that have clear workflows, machines that are easy to service and maintain. And the reports from my team were, they just work. They always work. And that is music to my ears.
Autodesk Research is a team that is innovating and looking far ahead. The performance-aided design workflows will be very important in the future. Firstly, because there are so many smart products that we're seeing every day that already have embedded sensors and getting data out of them. Second, there are so many requirements day to day to have more sustainable products and to have products that are better performant for that particular tailored operation. This project helps us to democratize that very highly skilled approach to wider scale of industries.
What really excites me is the possibilities it opens up in how you're able to fabricate things. It's not just, hey, we paid for a piece of equipment. There's something new that's on the horizon. Let's work together to find a use case for that. And that's what Markforged has done.